It's pretty wild to think about, but our entire digital world, everything we rely on, is constantly at risk from invisible forces zipping through space. And no, I'm not talking about aliens. The threat is actually a lot closer to home. It's our sun. And it's slinging a constant barrage of energetic particles our way that can cause some serious chaos for our technology. Let's get into it. All right, just so we're all on the same page, this is part 2 of a 5-part series where we're digging into a really fascinating report. It's called Real-World Examples of the Negative Effects of Solar High-Energy Particles Causing Single-Event Upsets on Earth-Based Systems. Yeah, it's a mouthful, I know. It's from the brilliant folks over at RFI Detectives who are part of Virtualization Options LLC. In part 1, we laid the groundwork on space weather. Today, we're going to focus on where that cosmic storm hits first and where it hits the hardest. So, I want you to think about this for a second. What is this invisible force? Something that can travel 93 million miles across the void and just mess with our most advanced, most sophisticated electronics right here. It's a threat that is always there, and sometimes it can be incredibly violent and unpredictable. Well, the answer is literally shining right above us. It's the sun. All this potential disruption comes from our very own star. Kind of ironic, right? The thing that gives us life is also one of the biggest natural threats to our modern way of life.
So how exactly does the sun cook up this trouble? Well, it's got a few different recipes. You've got your solar flares, these huge, intense bursts of radiation. Then there are coronal mass ejections, CMEs, which are basically giant eruptions of superhot gas. But the real troublemakers for our discussion today are solar energetic particles, or SEPs. I want you to picture tiny subatomic bullets, protons and ions, that get supercharged and blasted into space at nearly the speed of light.
And where do you think those cosmic bullets make their first impact? Well, that brings us to the main event for today, our satellites. They're out there circling the globe, completely exposed. They're on the absolute front line of this cosmic shooting gallery, which makes them by far our most vulnerable pieces of tech. And this quote from the report we're looking at just hits the nail on the head. See, down here on the surface, we're living inside a cozy, protective bubble thanks to Earth's atmosphere and magnetic field. But our satellites? They're way outside that bubble. They are completely raw and exposed to the full force of space radiation, taking a constant beating day in and day out.
Okay, so let's zoom way in. What actually happens when one of those particles, one of those cosmic bullets, slams into a satellite's electronics? Well, this is where we get to the core of the problem. It's a thing called a single event upset. And trust me, it's a microscopic event with some seriously major consequences.
So what in the world is a single event upset, or SEU?
It's exactly what it sounds like. It happens when just one single high-energy particle hits a sensitive spot on a microchip. That impact deposits a tiny bit of energy, just enough to flip a 1 to a 0 or a 0 to a 1 in the computer's memory. It's a temporary glitch. It doesn't physically break anything, but in that split second, it can cause the entire system to make a catastrophic mistake.
Now, I know what you might be thinking. Come on, it's just one bit. What's the big deal? Well, in the incredibly complex world of satellite electronics, that one little bit can be the difference between a perfectly functioning satellite and a billion-dollar piece of space junk. So let's follow the journey from that tiny cosmic ray to a massive system failure. When that single bit flips, it can set off a whole chain reaction of errors. It might be a simple bit flip in memory, or it could cause the processor to execute the wrong command. Best case, the satellite has a temporary glitch, maybe goes into safe mode, and engineers on the ground have to spend hours rebooting it. Worst case, that single bit flip leads to permanent damage, and the satellite is lost. Forever. And look, these bit flips aren't happening in some non-critical system. They are hitting the absolute heart of the satellite, its brains and its nervous system. We're talking about the main onboard computers, the telecom systems that beam data back to Earth, and maybe most important of all, the attitude control processors, the things that keep the satellite pointing in the right direction. Imagine a bit flip there. You could have a satellite just tumbling helplessly through space. And here's the real kicker, the paradox of our own genius. As we make our technology better, smaller, and more powerful, we pack millions, even billions of tiny transistors onto every single chip. But every one of those transistors is another potential target for a particle strike. So as our electronics get more advanced, they also ironically get more sensitive. We're basically creating a bigger and bigger bullseye for these cosmic rays to hit. So we've clearly seen the danger that's out there for our hardware in orbit, outside of Earth's protective shield. It's a constant battle. But that leaves us with a really important and, frankly, a kind of scary question. If this is what's happening up there in space, what happens when these energetic particles are so powerful they can actually punch right through our atmosphere and reach us down here on the ground? Well, that's exactly what we're going to explore in part 3. You're not going to want to miss it.